Hi, Mr. Luong. This is FRQ4. So for part A, I'm going to draw the free body diagram for Mass 1 using bird's eye view. So you told us the tension. Here, I make it a block so it's easier to see. And then there's tension going that way. And then there's also FG, but you told us to just make it like that. And then FN is gonna be, so that's FG, and that's FN, because from bird's eye view, the FN is like going toward us, and FG is like going down, so you can't really see it. But FN is going toward us, so it's just gonna look like a dot. And then the mass 2, it's going to look very similar, except the tension is gonna be greater. Sorry, tension is gonna be greater, and FG is gonna be like that, and FN is also gonna look like that. Okay, now to calculate for the period of the outer block M2, I know I can do V equals 2 pi R2 over T2. Oh, that's for period, not the tension. Here, I just put T as that because you don't need a subscript for the period because you have the same period for both blocks because they're both connected, so they're both gonna go at the same time and finish a revolution at the same time because they're connected. So then it's gonna be T equals 2 pi R2 over B. T equals 2 pi 0.75 over V is 4. So T is going to be around 1.18 seconds. And now to calculate the tangential speed for the period M1, for the inner block M1, I'm going to use the same thing, V equals 2 pi R1T. And like I said before, since the period is the same, I can plug in 1.18 for the T. So R1 is going to be 0.4, 1.18, and then, so you should get the, oh, this is part D, by the way. Part D. Okay, so you should get about, I say, 2.13 meters per second. Which makes sense because since it has less radius, the velocity will be less. Okay, so for part E, I have to derive an expression for the radial centripetal acceleration AT of the inner block in terms of R1 and T. Oh, AR and T. Yeah, AR. Okay, so for part E, I know V, I already know that V equals 2 pi R1 over T. But I know AC is V squared over R. So I want to square that V. It's going to be 4 pi square R1 square over T square. And then, so then I just put this and divide by R. So AC is going to be 4 pi square R1 square. That's going to be R1. over t squared. So everything of b squared over r1. So t squared over r1. So that cancels out. So AC is going to be 4 pi square r1 over t squared. Okay. For F, I'm going to use what I got before. So I'm going to use this formula right here to find that ratio. So you want a ratio from AC of mass 1 to AC mass 2, right? So for AC of mass 1, you know 4 pi. And then the radius 4 pi squared, the radius of M1 was 0.4. And then for the tension, is going to be T squared. And then you want this over the 4 pi square of the radius of 2. And since like doing that will make it go reciprocal, it's going to be T squared over 4 pi square of 0.75. So then the t squares cancel, 4 pi squares cancel. So basically you just have 0.4 divided by 0.75, which is 0.53. Then for the ratio of FC, it's going to be FC M1 over FC M2. So basically, it's basically just AC, but with M. So it's going to be with like this, but with you just have M in the front. So the M of M1 was 0.5, 0.05. And then B squared over R, which is AC, which is just... Oh, and also, like before, the 4 pi square and the t square will cancel, but I'm still going to write it just to show. And the mass of the 2 was 0.03. 0.75. Okay, t squared cancel, 4 pi squared cancel, so that just leaves you with the mass and the radius. So then putting in your calculator work, you should get, hold on, sorry, 0.03 times 0.75. You should get 0.89 for the ratio. And then for part H, it asks what is the magnitude of the tension. So H, I know the tension is for T1, it's going to be the centripetal force. And I'm going to use the formula I got above for centripetal force, which is going to be 0.05, 4 pi square, 0.4, t squared was 1.18 squared. So the centripetal force is going to be like 0.57 newtons. And then for part J, I can use the ratio I got before from FC M1, FC m2 equals to 0.89 to solve for the centripetal force of mass 2. So then you divide that by 0.89. So Fc m2 is going to be 0.57 divided by 0.89, and centripetal force should be 0.64. And then for part J, the magnitude of the net force acting on the inner block M1 is, oh wait, sorry, this is part I and this is part J. And then the magnitude of the net force acting on inner block M1 is basically just the Fc M1. So the net force would just be the centripetal force of M1, which is gonna be 0.57. And then for part K, if the system is replaced with two blocks that are more massive while keeping all the other components the same, what would happen to the magnitude of the tension T1 and T2? So I think both of the tensions would increase. I think both tensions will increase because since you have more mass, but everything else the same. So let's do Fc equals to mv squared over r. If mass increases and everything stays the same, and also Fc equals to T, so then that's gonna be T. So if mass increases, then so will T increase. And since this is the same but mass increases, then T will also increase. And logically, it also makes sense that for your masses to have the same velocity, but you need to have more force pulling the masses for it to go the same velocity, because you need to put in more work for heavier masses to go at the same speed.